Hello students, welcome back to the another session of our data structure journey. Right now we are covering the graph data structure. As we know, graph is a nonlinear data structure which is consist of set of vertices and edges. Last video we are cover how to represent graph in a computer. We are already covered three type of representation of graph. Right now we are going to cover how to traverse a graph. Traverse a graph means how we have to visit each and every node present in a graph. There are two ways graph traversing can be possible. First one is the depth first search. Second one is the breadth first search. In this video, we are going to cover depth first search. By the name depth first search, this is a one type of recursive algorithm for searching all the vertices or node of a graph or tree structure. This algorithm we can able to use for the tree also. This algorithm traverses a graph in a depthward motion and uses a stack to remember to get the next vertex or node to start a reach whenever we reach and searching a process when it is dead end occurs at any iteration. It may happen because we are going to depth wise. So whenever we go depth, there must be some ending point, but this is not the end of the all the vertices. So again, we have to go back to the another node. For that, we are using the stack data structure. So for stacks become data structure, there are two operations, that is the push operation as well as pop operation. How the operation is going to pop up, I have already make a video. In this description section also, I put the link, so you can just go for it. Otherwise, whenever we go for the implementation of depth first search, you may face some problem. For example, in our problem, it is given this is our starting node. So push the starting node or vertex into the stack. So which node we have to insert? We have to insert B1 into the stack. So this is our stack. Here what happened? This is called as the push operation. Means insert an element into the stack. We call that the push operation. Next operation we call as the pop. Means delete an element from the stack is called as the pop. So it is nothing. It is a collection of elements where insertion and deletion is going from one end. Means from this end we can able to insert as well as we can able to delete. Insert element into the stack is called as the push operation. Delete an element is called as the pop element. So first push the starting node. So we push the starting node. We push it to B1. Repeat until the stack is become empty. Right now stack is not empty. Pop a node from the stack. So which node is present inside the stack? That is B1. So we have to pop it. So once we pop it, means we remove from this one. Then what we have to make? We have to make the B1 as a visit the pop node. So we make the visited. Means this node is visited right now. Push all the unvisited adjacent to the pop track. So here, what are the node is unvisited adjacent? So B4, B2. Now you may insert B1 for B4, then B2 or B2 or B4. Any sequence we can follow. It is our choice which sequence we want to follow. Whatever sequence we follow, throughout the traversal, we have to do the same thing. For example, I insert B4, first B4, then B2. B4 and B2 both are adjacent to the B1 vertex. That's why we are pushed into the operation. Push sequence can be any order. Then we have to repeat pop and node from the stack. So pop means B2 we have to pop and we have to make this one as a visited. What it mention? Here it is mentioned pop a node from the stack. Visit the pop node. So now after that we make B2 as a visited. Push all the unvisited adjacent pop to the stack. So visited plus from B2. B1 is adjacent, B3 also B6. But B1 is already visited. So what are the adjacent node we have to insert? Unvisited. Unvisited right now B3 and B6. So we have to insert B3 and B6. Then we have to pop a node. So pop means B6 we have to pop. Now we have to pop the B6. Once we pop it, we have to make as a visited. And we have to push all the unvisited. So now from B6, B2 is present, but B2 is visited, unvisited, V3, no, V3 is already present inside, so we cannot push anything. Then again we have to pop one. So now we, which topmost element is the V3, so we have to pop the V3. After V3, we have to add all the unvisited adjacent node. V2, from for V3, V2 is present, but V2 is visited. Then V4, V4 is already inside the stacks. Then V5. V5 is unvisited, so we have to insert the unvisited. Now we insert the unvisited. Then we have to pop a node. Pop means anyhow topmost element is going to be pop. So here we have to pop which node? Node is V5. V5. After that V5, all the unvisited. V4 is visited, V3 is already visited. V4 is already inside the stack and V3 is already visited. So there is no node is present unvisited. So next what happened? We have to pop this one. So pop means V4 we have to pop. V4 is the pop node. So V4 is the pop node. There is no element, repeat the until the stack becomes. So now we are visited all the node or not? V1, there are how many elements? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we are already visited the node. So this is the way the depth first search algorithm perform its operation, or we can say this is the way we can traverse the graph. How we traverse? Right now, V1 to V2. So this is the way. Then V2 to V6, V6 to V3, V3 to V5, V5 to V4. So now this is the traverse, or we can say path. Path is B1 to B2, B2 to B3. So next one is the what is the time complexity of this algorithm? This algorithm time complexity order of B plus C, where B is the set of vertices or set of or number of nodes or a vertex. E is the number of edge or set of edges or link. Next one is the space complexity. Space complexity is the order of B, that is where the B is the number of nodes or number of vertices. Next one, where we can use the breadth first search. So for finding the path from source to destination. So if we go for the DFS algorithm, then we can know the where is the path from the source to destination node. To test if a graph is bipartite or not, we can able to use this algorithm for finding strongly connected component in a graph or for detecting a cycle present inside the graph. If there is a cycle is present or not, by this algorithm we can able to find how to do. If the node is visited twice, means we got find out that there is a cycle is present. Hope you are able to understand the concept of depth first search algorithm in a data structure. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so much.